Today we are going to study about the DMA controller, Direct Memory Access Controller. Direct Memory Controller, Direct Memory Access Controller is used to transfer the data from IO device to the memory or from memory to the IO device without the help of CPU. So this is done to make the data transfer faster without the help of CPU, right? Now, if we need to transfer any data, what are the information that we require? Like what are the information that DMA controller will require to perform the sharing of the data? First, source is required, right? Source, destination, word count is required, right? From which source the data transfer is performed and from which source address. And where the data is to be sent, the destinations, or which address means the address of the destination, and how much data it needs to be sent, like 10 images, 20 images, one video, 5 video, like that word count byte of the data is to be known. And the operations, like which operation, read operation, write operation, and what is the mode of the operation. This source and destination addresses is sent to the address bus. So there is in this is the internal bus, and this has all the three buses: address bus, data bus, and the control bus. And to store those, there is the data bus buffer, the address buffer that acts as the bridge between the DMA controller, IO devices, and the memory chip. The source and destination address is stored in the address register, and the word count is stored in the word count register. Then the mode and the operation, read or write operation, is stored in the control register. And these all the blocks are controlled by the control logic, which is the brain of the DMA controller. Now this is the block diagram of the DMA controller. It contains the two buffers, data bus buffer and the address bus buffer, and four register: address register, word count register, control register, and the register that sends the status. And these are the signals that is required by the control logic. We'll discuss this in the next data transfer. So let's move on to the data transfer. Now this is the DMA transfer in the computer system. This is direct memory access controller, DMA controller. This is the CPU. This is our RAM, and this is our input output devices. Now let's take an example. We inserted a pen drive in the computer and we want to transfer or open the 10 images. 10 images from that pen drive. First image is here, second image is here, and all the images are here respectively. Now, first we inserted the pen drive in the computer, right? Pen drive is the IO or the peripheral devices. Then we copied these all images and moved or opened, whatever the case is, moved or opened that images. Now the OS operating system first comes into the play. The operating system goes to the CPU and it tells the CPU that 10 images is need to be transferred, and in this destination the data is to be transferred, and this is the source and their addresses respectively, and the mode is this: read or write operation. Now CPU gets the informations, then IO or peripheral devices request the DMA controller to perform that operation. It sends the DMA acknowledge signal. Then direct memory access controller sends bus request. Hello CPU, please empty the bus. I want these buses to transfer the data. Now the CPU sends whether it is the read or write signal, address, source address, destination address, and the word count and all others the data. That is sent by the CPU to both RAM and DMA controller. Now this is the direct memory access controller enable signal. When this is 1, this DMA is selected and enabled. When this is 0, this is not selected and disabled. And this is the register select. Which register is to be selected? There were 4 registers, right? Control register, status register, data register. So among those 4 registers, which register is to be selected is known through this signal register select. And is this DMA to enable or disable? This is known through the DS signal. These are sent by the CPU through the address bus. And this is the address select. This is the decoder. This decodes the address and converts it into the DS signal and register select signal. This DS signal is also called the chip select. Now all the data is transferred from CPU to DMA controller. Now this CPU says, okay, your boss request is granted. BG, boss request granted. Now DMA controller is ready, right? So this will set DMA request is acknowledged. Sorry, this figure is mistake. First of all, IO devices request the DMA, and then DMA acknowledge and sends the IO peripheral device that your DMA request is acknowledged. Now the data transfers between the RAM IO devices occurs from this data bus, address bus, and the control bus, everything. And then after the completions of the data transfer, the DMA controller sends the interrupt to the CPU. The data transfer is completed. Now you can use this data buses. You can use these buses to perform your own operation. In this way, the data transfer occurs between the memory and IO peripheral devices. Let me explain it once again. First of all, we select whatever the data is to be opened or transferred. Then OS sends goes to the CPU, gives all the informations about that data. Then that information is transferred to the access controller. IO peripheral device requests the DMA controller, DMA request. Then DMA controller requests the bus to be emptied, bus request. Then the CPU sends all the data informations as well as the bus granted. Bus is emptied, now you can perform the operation. Then DMA controller sends DMA acknowledge your direct memory access control request is acknowledged. Now I'll be helping you in performing the data transfer. Then the data transfer between the IO peripheral devices and the memory occurs with the help of DMA controller. After the completion, the interrupt signal is sent to the CPU by the DMA controller, saying that the data transfer is completed. Now you can use BOSS for your own purpose. In this way, data transfer in the computer system using the DMA happens. Thank you.